start the recording. So I know most of you, but for those of you that I have not had the pleasure of meeting, welcome to the show. My name is Lisa. You can call me Dr. Hoffman if you insist, but just Lisa is fine. It is spelled Lesa, but it's pronounced the usual way, Lisa. The story behind that, as I may have told you, is that my mom told me when I was born that I look like a Lisa, but not the regular kind. So we're sticking with that. That's my story. Um, my setup here, so I record all of my classes. I have been recording them since before it was cool, like in 2010 or something. Initially with a wireless microphone and an MP3 file, and now with this whole cool setup. But the way that this works is that I have a dual monitor. I'm staring at my laptop, which has all y'all faces in the chat window, and then the monitor over here is the one that is going to be recorded, where all of the material that I'm presenting is going to be. So the end result of that is that the recordings will not include any of your faces. It will just include the screen share that you see as well as my audio. So it will pick up your audio if you speak aloud. That way people who are watching the video can hear what the questions were. If you don't want to talk or you can't talk, if you're on a phone or don't have a microphone, that's fine. I have the chat window here and dare I say, I've gotten used to trying to keep track of it. My favorite feature about Zoom teaching is the anonymous feature of the chat window. So if you're somebody who is too shy to ask questions and you feel like you're going to look stupid, you can send your question just to me and I will repeat it for the class and try to answer it. So please don't let anything be a barrier to fully participating. For those of you who have your cameras on, thank you. It makes me so happy to physically see you. For those of you who don't have the bandwidth or for whatever reason don't want to put your cameras on, that's fine as well. Just make sure that you let me know if I can do anything for you during the class in terms of answering questions. I want this to be a conversation, so please don't ever feel like you're interrupting me. I get really excited about this, and especially this time of day when all of the caffeine is fully on board, I can start going fast and start talking fast. Don't ever feel like you're interrupting me to ask a question. And you can turn on your microphone and interrupt me, like get my attention that way, or you can try to use the chat window and I'll call on you. If I didn't want to talk to you, I would do this asynchronously, right? I just record the videos in my basement and be like, good luck, there's your material. But I want to talk to you because I feel like this material, um, the things that I teach it's real easy to get lost and then not get back into it. And so if I can clarify any small definition or terminology that will help you stay with me, the better. And if there is anything that you need to hear again, you're welcome to review the recordings as needed. So let's see here. In terms of materials, you don't have to buy anything. My textbook, I learned, is available online. And not only is it online, you can just download the whole thing, which I was like, what? I had no idea. But yes, that is apparently within the publishing rights. The textbook for this class is my book. It is a labor of love that I spent 5 years on, and I wrote it for this purpose. So the background is that I've been teaching longitudinal models. It was actually the first thing I ever got to teach in 2004. And I struggled to find a textbook that I liked for this topic because they were either written for multi-level models for clustered data where they had like one chapter on longitudinal. And so I spent the whole time with students going, what does students in schools have to do with longitudinal? And the connection was hard to make. There are a number of longitudinal books that are written for statisticians by statisticians, and those tend to be not quite as accessible. And so I wrote the book to teach from. So that is to say, unlike some of my other courses where I was like, you can take the readings or leave them, it's up to you, I actually feel like reading the book will help you because it's going to follow exactly what we're going to cover. And the way that I wrote it is thinking like, okay, how would I teach this topic? I just started typing what I was going to say. So it will match very well. So if I start talking too fast or if there's things you're unclear about, referring to the book should help you. That being said, I added a number of other articles that are more like other things that you should know about this topic or current research on this topic. And so those are going to be sort of extras if you have time to be able to read them. And let's see. So this course is going to meet 2 to 3:15 Tuesdays and Thursdays, office hours in the same room starting immediately after class until 4:45. It's the same deal as before where it's group-based office hours. So all of you are welcome to come, hang out, work on assignments, get your questions answered, work in the background if you want to, pop back in with questions, however it works for you. I have 31 folks in this class. I only have 9 in the other class, but that's still a lot of people to try and help. So I'm going to do my best to use those hours to help as many people as I can. That being said, if you would prefer to meet with me one-on-one, you can certainly ask for an individual appointment and we can do that. I will never be in the building. I'll just put that out there right now. For those of you who are still going to work, I am never going to be there. So if you hang out by my office hoping to run into me, that is a bad strategy. The only place you are likely to run into me would be at Huey's Montessori daycare to drop him off at school in the morning, or at the Hy-Vee grocery pickup lane, which I am known to frequent as well. But if I run into you in those places, I might be a little afraid. So you're not going to run into me in person, but I'm usually very quick with email, and I'm happy to meet with you individually as well. Okay, any questions so far? All right, then can you all see my yellow slides? Okay, so I made this to try and keep myself from rambling too excessively in introducing this course and the logistics. So let's start then with a little more about what to expect this semester. Make sure I am recording. Yep, I'm recording. Good. I've been known to forget to turn it on. That's a technical difficulty that only I am responsible for. So what are we here for? Longitudinal models broadly construed. So we're going to study analysis of repeated measures over the same sampling unit. And that is to say units can be anything. I am going to default to talking about units as people. So people measured repeatedly over time is sort of my bread and butter. But if you are from a context where you're studying, say, countries repeatedly measured, or organizations repeatedly measured, animals repeatedly measured in some cases, any of that is equally applicable. Repeated also is a very general term that means that any scale of time is going to be appropriate for these models. So the traditional longitudinal study is occasions that are far apart in time, far enough to where you would have time to see change happen. So whatever that would be depends on the phenomenon that you're measuring. But nowadays, you can have measures literally every second of the day. There are examples, say, of studies that use smartphones where they ping you and you answer some questions, and then they ping you again and you answer some more questions. That's equally longitudinal as studies that occur over many years. So the methods that we're going to cover, there are some approaches that are better, so to speak, more suited for shorter measurements, and some approaches that are more suited for longer measurements, but we're going to do all of it. And I
Lisa,
know, yeah, please go ahead.
what about the extreme of that, like functional MRI studies where they're collecting data of how the brain's changing over seconds?
Yeah, that's a bit trickier. Yeah, I think to some extent the models can be extended to those situations, but there may be other patterns that are present. Cyclical patterns, wave sorts of patterns, that's not something that I have planned to cover, but I can probably direct you to sources that would cover those. This is mostly thinking about like monotonic kinds of change for the most part, or else fluctuation to where there is variation, but it doesn't follow particular functional forms.
Okay.
Does that help?
Yeah,
Okay,
thanks.
great. Thanks for the question. So repeated in this case, by the way, also can be not just time, but other things. So there are experiments in which people see the same items repeatedly or the same stimuli, that kind of thing. These models work for that. And I have a week planned on what I call models for other kinds of repeated measures data. That is chapter 12 of the book that if I have time, we'll go over it. And if not, then you have the resources from the last time I taught it. So that is to say that I hope that we will cover models that will be useful to all of you, no matter what kind of longitudinal data you came prepared to work with. So as is my usual, I want you to have fun with this. I want this to be useful and not scary. So we're not going to calculate things by hand, with very, very, very few exceptions. You might have to plug a couple numbers into Excel, but that's it. We're going to make the computers do the math for us. And in these models, we literally couldn't do it ourselves even if we wanted to. We're going to use something called likelihood estimation, which is an iterative process. That means sums of squares and all that stuff that we could do by hand is not going to be a thing. I'm not going to spend my time doing derivations or proofs. I am not a mathematician, and I trust the people who did that stuff to have gotten it right and that we can use their results. And I'm also not expecting you to memorize things. I want you to be able to understand the logic and apply decision-making rules accordingly, but you don't necessarily have to have that at the tip of your fingers. If you have the vocabulary, you can always search for what you need to expand on whatever technique you're trying to do. This class is going to be a lot of working memory. I know I've said that before about my other classes, but this in particular. I know several of you took structural equation models with me last year. Can I get a show of hands? Wave. Yeah, that was a big class as well. For people who've taken that course with me at previous universities versus this course, I have been told this one is harder. But it's not harder because it's more difficult. It is harder because it's more complex. So the difference to me is that any one thing by itself is fine. It's that you're managing 10 of them at the same time. That's what makes this course more challenging in terms of working memory. We're going to be building multiple types of regression models simultaneously that each do something different within the scope of the overall analysis. And keeping those straight and the vocabulary and the notation that goes with them, that's the part that is challenging. So we're going to spend a lot of time drilling vocabulary and drilling notation so that that stuff gets embedded and automatized. That way you'll have room to add things to it. So that's what I expect the difficulty to be, is just keeping things straight. I am not going to give tests. So for those of you who haven't had me before, I don't believe in tests at the graduate level. I don't think they're useful. I am also not assuming that you know anything past the general linear model, which is something we're going to review this week. So if you've had basic regression, where you're predicting quantitative outcomes and you know how to interpret that type of model, you're good to go. That's all I need from you. However, if you have had advanced coursework, such as structural equation models or other things, I am going to try to make connections to that world for you because I want you to understand how these things are related. And if that doesn't make sense to you, that's fine because that's another course. But there's a significant amount of overlap in how people approach longitudinal modeling from a multi-level modeling perspective, which is the one that I'm going to take, and from a structural equation modeling perspective. There's a direct overlap there that I want to make for those of you who are ready to make it. So what are we going to do this semester? My typical course framework is operating for this course as well. I have a combination of formative assessments and homeworks. So formative assessments, I've got 6 of them planned. Each is worth 2 points, so it's out of a 100-point scale. And the idea is that you're going to log on to Icon, answer 2 to 4 questions that are meant to be sort of general review. So I might ask you about terminology, about kinds of things, about procedures, and these are questions that you should be able to answer mostly off the top of your head. If you can't, that's fine. Dig into your notes until you find the right answers and write them down. And hopefully this is a way to convey to you what you should be reviewing. But then these, when they come back on my side, They're due either on a Monday night, which is where I've got them all right now, or if I need to move them, they'll be on a Wednesday. That way I can look at your answers the following morning before class and see if there's any common misconceptions or anything that I need to elaborate on. And if you're not sure what to write down, like you can leave me notes in there and say, yeah, Lisa, I have no idea what you're asking here. Or I think I'm on the right track, but I'm not sure if this is what you meant. Those sorts of things help me either clarify the wording or else know where the confusion lies. So this can be a conversation between the two of us. I'm going to give you points for doing them. So they're not graded for accuracy, just make an honest effort and you get your points. The other thing that you'll be doing is homework. I have 6 assignments planned worth the other 88 points for your grade, and these are in the online homework system that most of you are familiar with. This semester, though, there's going to be no individual data analyses. These are all canned data. I used to let people do their own analyses of their own data, like project like. The problem that comes in with that is that the experience of what you end up needing to do is so heterogeneous that I can't be sure that you're going to encounter all of the same difficulties and learn all of the same things with your own data that you would if I set up those hurdles for you. So for that reason, all of these are going to be canned assignments and 88 points for doing those, as I said. 1 point if they're late. So to provide an impetus to stay up with the class, because it is cumulative in terms of what the material covers, if you submit it late, it's off 1 point. That being said, there is going to be a homework 0 that will be available, I think, starting next week once I make sure that I get all the adds or the drops for this class, and you get 3 points extra credit for completing that. So basically, you can turn in half of your assignments late and you still are fine. What I'm going to try to do is link the material that we're covering to real world research and examples as much as possible. And for those of you who have longitudinal research that you're actively involved with or you're reading about, please, please, I absolutely love those kinds of questions to where you're like, well, is this like this other thing I was just reading about the other day when they did this? Those are the best kinds of questions because it brings new examples into the fold, and it allows me to talk about how these things interface with things that you actually care about. So if you have those kinds of questions, please feel free to send them to me either via email or to bring them up in class, whatever you feel like. Okay, no, go ahead. All right, so my job is to provide you with materials. The thing about the assignments is I will never ask you to do something in a homework that I haven't shown you a version of exactly before. So your job will be to take the examples that I give you and to change them up, customize them, tweak them to make them fit the homework. So you don't have to be asking the Google for how to do any of this, right? Do not go to Google University. This is why you're here and paying your tuition dollars is for me to be able to help you. And if you don't know how to do something or how to get started, please don't hesitate to reach out and I can help put you in the right direction. Questions. So I prefer it if you bring up your questions during class because that way everyone else can hear the answers. And you know what they say, if you had the question, someone else probably has the question too. But I will add to that. If you have a question and someone else already knows the answer, do you know what you just did for them? You made their day because they're like, hey, I knew the answer to that. I know this stuff. And you made them feel good. So give that for each other, right? Bring the questions to class, make each other feel good, or help them fill in the blanks. When I was first learning this material, when I graduated with my PhD, I knew just enough to be dangerous. Like I could make SAS run these models and spit out numbers, and they look plausible. And I was like, and I even had a paper or two where I tried to run the models. And then I was a postdoc at Penn State University, which has a very strong methodological focus in their human development program. And I got to audit some courses as a postdoc. And I was the person with my hand in the air every 5 seconds asking questions. I annoyed the crap out of everybody, I am quite certain. But that was how I started to put things together. And so I want each of you to be that person. be that person who's not afraid to put things together, to ask questions. You can do so anonymously in the chat window so that you don't know that. So if you're afraid of being the annoying person, but I really do think that that will help you. Um, so I will answer the questions if you ask them. So your end of the bargain then, ask the questions, review the material. If you can practice on data that is meaningful to you in addition to the homework, that will help you the most because there is a magic that happens in translating abstract concepts to something that you really care about. There's a cementing that happens that you cannot duplicate inside the classroom. And don't wait till the last minute to ask for help with homework. I can't promise to be online Friday nights at 9:30 and to answer questions about homework that's due at 11. I can't promise that. I am an old person who goes to bed usually by 9:30. That's where we're at here. Because I know that my 5 and 5/6 year old is going to be banging on my door at 7 a.m. at the latest. So that's what I know is going to happen. All right, so let me pause. See, I'm at the Diet 7 Up. I've had my quota for caffeine for today, in case you couldn't tell, and see if anyone has questions or comments so far. No.
I've got a question.
Yes,
Just
please.
using SAS. I've never used SAS before. Use SPSS and Stata a little bit. Is that likely to be a problem?
Oh boy, that's a great transition. Did you know that's where I was going next?
Okay.
Because you just set me up beautifully to talk about the software. So yeah, software. Okay, here's the deal. Um, I have been teaching this material in SAS as the primary thing basically my whole adult life and learning this. SAS is the most comprehensive when it comes to options for modeling univariate longitudinal data. Less so for multivariate, but we're not getting into that until the tail end of the course. And its estimating routines are the most stable. That's why I favor SAS. However, not everybody uses SAS, particularly in countries in Europe where it's not a thing, I am told. So over the years, I have had to pick up other things. The good news is that given that this course mirrors the textbook quite directly, I spent a year building a website that I call pilesofvariance.com. Yes, that is my domain name. That was actually a birthday present from my husband because I had wanted piles of variance from my book and he went and got it for me because that's what stats nerds get for each other for gifts is domain names, things like that. So pilesofvariance.com has every single model in the entire book in 4 different packages. So it has SAS, SPSS, Stata, and M+. Now that being said, I add examples for this class that are not in the book, particularly when you get to predictors, because I want you to have more than one. So here's my plan. SPSS will do the majority of what we're going to cover in class, and I have used it enough to say with good confidence that you will get the answers that are correct enough to feed into the homework portal to be counted with the level of precision that it grades, so within 100th or 1,000th, whatever I pick for that. SAS syntax and SPSS syntax for mixed, which is what we're going to use, is very, very similar. SAS came first, and I think SPSS sort of used it as a template. So with very few switches in terms of this is this, you can convert SAS syntax to SPSS with no problem. I'm not going to add it to anything for this course, though, because it doesn't have extensions for generalized versions of these longitudinal models. So when you're predicting an outcome that's not normal, like binary categorical counts and that kind of stuff, the last I checked, SPSS only had quasi-likelihood estimators rather than full likelihood estimators, and so those are generally not as good at recovering the random effects variances, and so I don't use it for that. And SPSS also doesn't directly have anything that extends into multivariate models, so path analysis type things. You can do that in its AMOS package, which is separate, but AMOS doesn't have as many options as Levon in R or M+. So if you want to learn how to do SPSS, I can help you sort of on the side, but that's not something I'm planning on focusing on. When I say stable, do I mean consistent and doesn't blow up? Yes. Comes up with the same answer that other programs comes up with, and handles extensions. So there's certain types of models, what's known as crossed random effects models, where SAS and SPSS will spit out the exact same answers very quickly, but Stata, for instance, has a hard time with those sorts of models. When I was building the 3-level models, I had, that was chapter 11 of the book, I had SAS and Stata run just fine, no problem, but SPSS threw up. So it just sort of depends. At some point, the program is meant to do certain things well and other things maybe not as well. And so you may hit the limits of that when it comes to these sorts of models that have increasing layers of complexity. So yes. Lane, does that answer your question about SPSS?
I think so.
Okay, I can help you with it. It's
Yeah.
super easy to translate. And actually, I have taught workshops with these models where I included SPSS as one of the packages. And so on my website, if you go to the workshop side, you can see material to where I have the same model in SAS, Stata, and SPSS simultaneously. And then you can make the translations, and I'm happy to help you with that.
Okay.
Um, yeah. Stata. I know Stata well enough that I am pretty confident I can throw Stata examples into anything that doesn't already have them and add that for this class. So I thanked all of you who completed the survey I sent out as to what packages that you use. It's kind of split 3 ways in terms of what people are used to. There's a good contingent of SAS people, good contingent of Stata people, and a good contingent of R people. So I'm trying to make everybody happy. So I'm planning on adding Stata to the unique class examples, and Stata is up on piles of variants, and so there's a lot of examples using Stata. I say as my time permits, because if you met my almost 6-year-old, if his school gets shut down, then my workday gets cut in half every day. And that happened last spring. So I'm trying to be realistic about what I can promise. If life goes on to where everything is okay and he's in school, I anticipate being able to add to the SAS stuff. But if things go south, then that may have to be one thing that I drop. But I'm pretty sure you can use Stata for the homeworks because I've seen enough examples of these types of models where they return the exact information as SAS. So Stata should be fine. Now R. The R users here. I have learned R for the past like 2 weeks or so. My husband has been trying to get me to learn R for years. Years. And I have resisted. I have fought it tooth and nail. And there's enough people now where like I realize this is a language that I need to pick up even if I'm not going to use it in my life. And I gotta tell you, I finally drank the R Kool-Aid and it tastes like someone forgot to add sugar. It, I was like, what? What? I am not a fan. I'm not a fan. But um, I am trying to pick it up because I want to add it to the Piles of Variance website and I want to be able to converse with students who use it. So I am also planning on adding R to my examples. I haven't used it enough to guarantee that I will get the exact same answers out of the homework portal if you use the other 2 programs. But in cases where that's not going to happen, I can envision a workaround that I've had to use in the past. So this is to say, I anticipate that you will be able to use SAS for sure, Stata most likely, and R, I hope. And that's what I can say right now. The problem with R is that there's 18 ways to do the same thing. And I haven't learned which ways work best for which situations yet. There's LME, there's LMER, there's NLME. Like there's all these permutations of packages that people have written, and it's the extent to which their estimation is stable depends on the people writing the package knowing what they're doing. So that's why I'm hesitant to promise that. Um, Most of you, I think I looked, and of the people who responded, everybody said they were comfortable using at least one of those packages. I am going to go over the code for all of them, though, if they make it into my examples. And so this is your chance to pick up another one. Most of you are in the process of building your CVs, right? You all started your CVs and you see that there's a lot of empty spaces where you hope to eventually have more things. So there should be a section, if you don't have it already, called Technical Skills, where you list all of the packages to do research related things that you know how to use. So if you can set up a Qualtrics survey, ching. If you can work with Microsoft Access, ching. If you know how to use SAS, ching ching. R. I've been getting announcements through the EMS listserv for internships, and I'm noticing that most of them say explicitly that you need to know one or more packages, and they list SAS, R, Stata, and SPSS. So if you're familiar with one package, this is your chance to try and pick up more than one and to be able to potentially work with different people. One of the things that happens is that people learn how to do something in one package and then they're sort of tied to that package. I don't want that for any of you. I want you all to have skills and to be able to move across packages as you need to be able to fit whatever particular kind of model that you're trying for. Now, that being said, with one caveat, M plus is something that I am very well acquainted with. I have put in examples on the Piles of Variance website for it, but we cannot use it for most of this class because it does not have a residual maximum likelihood as an estimator. So it will not give you the same answers for your standard errors and for your p-values for the homework system. So at the very end of this class, the last week or two where we're going to be focusing on multivariate models, we'll be transitioning into M+, because those you cannot do with directed effects between outcomes in Stata, or SAS, excuse me. You can do them in Stata to some extent, and you can do them in R to some extent. So M plus is not something that we can use until we get to that point. Okay, a lot of words about software. Are there any questions about that? And by the way, if you see that I have done something that is either inaccurate or you know an easier way to do it, I will so not be offended if you tell me. So for those of you who are better at R, I want to learn from you too. Because at this point, it just seems like a damn headache to be able to do anything. And that's what it feels like when you're first learning a stats package, right? A damn headache, no matter what it is. So in a way, it's humbling to put myself back into that position of feeling like everything is overwhelming again.
A
All right.
question, Lisa.
Yeah,
Um,
there you are.
if sorry. So in the last class that I had with you, I stuck with SAS the whole time.
Mhm.
And maybe this next slide is going to answer my question. So I'm not necessarily opposed to looking at a second package if we're going to kind of be able to, I guess, look at how to set it all up again. But I don't know what to choose. And so that's why I'm like, now I see your next slide and maybe this will help.
Possibly. The primary reason people give me for switching to R is that it's free. That is the first thing that people say. And to that, I always say, yeah, you get what you pay for, um, which is also true. So, my husband once taught with an R package at a workshop to do diagnostic models, and he ran an example in class that came up with a probability of 1.3. Wait for it. Can you have a probability of 1.3? No. So yeah. So that I always view as a cautionary tale, that kind of thing. So if you're looking to pick something up, Jacob, like R would be the thing that everyone says you should pick up because it's becoming the way of the world. It's something that I think businesses as well as academics would value that skill set. I don't have enough experience in R to say what's good about it and what's bad about it. That's what I'm trying to pick up. But I do have enough experience with SAS versus Stata. So in terms of the pros and cons of the packages, I think that SAS is better at working with multiple data files and raw data files simply because you can have more than one open in memory. So you can merge things, you can split things, you can subset, and have all of that going on in memory and not have to save any of it. You can just save your code that does all of the operations. And so I've written SAS programs, for instance, that inputs an entire file's worth of separate Excel files and stacks them on top of each other. Like that's 3 lines of code in SAS. Stata has created a way of handling multiple data sets simultaneously in their last version, I think 16. I haven't played with it yet though. Molly, you have the info on that? I saw you nodding.
I just Googled it because when I remember, I waited till after my first year to buy a package, and then Stata came out with 16 right before I was getting ready to buy, and they're like, now we allow multiple data sets, and I was like, oh, I feel like I remember seeing that, so I just Googled it, and it says multiple data sets in memory. There's a whole explanatory page about it if people want the link.
Okay, put it in the chat window. Yeah, I had heard it. I haven't played with it. A question about Mac versus Windows. If I have a Mac, are we okay to use the virtual desktop for SAS? Yes. The virtual desktop holds SAS, Stata. I think it has R too, although the point of R is that you can have it on your own machine, so I probably wouldn't recommend that. And it works whether you have a Mac or Windows the same way. There can be a bit of a hiccup in getting it to recognize where your files are because the slashes go the wrong way in Mac versus Windows, but I can help troubleshoot that if you need it. In terms of within dataset manipulations, Stata has some things that are streamlined, where something that would take 3 steps in SAS takes 1 step in Stata, so there's some nice things about that. Data analysis, I'd say certain SAS has the advantage for some types of models, maybe most. But then again, I also don't work with survey weights. So that's the big thing when people who use Stata, I think from the get-go, they need to incorporate sampling weights and whatever else they're called, stratum, and what are the other words I'm thinking of? Kelly, where are you? Yeah, she says yes. Those things where you have to identify the levels of sampling and selection. Stata has things that are built in that make that much, there's more options than there are in SAS. Stata wins for post-estimation stuff. So being able to get predicted values as a function of your covariates, being able to get simple slopes, mean differences, stuff like that. There's some stuff in Stata that's very slick that SAS makes it have more code. And then automation. I know how to program in SAS to make it do the same thing over and over and over again. There are ways to do that in Stata. I'm just not well versed in that because I've never needed to be. But R also has that programming language capability that people like to be able to automate certain tasks. Population correction factors and stuff too. So yes. All right. So Jacob, does that help you make a plan?
Yes, it helps. I mean, it's still going to be me kind of thinking about it and looking at maybe a couple things.
That's fair
but
enough. Or talk
but
to
I
the
don't know.
people you work with.
I like the way, I've already kind of been. I don't. In the last class that I had with you, Stata was like the other alternative that was talked about the most, and so I'm kind of like, I feel more acquainted with Stata already. Like, we've never really talked and hung out, but we've met.
You've seen them around.
Uh,
Yeah. Talk to the people that you work with also. They may have an opinion about what they're most familiar with and what they need you to learn. Often that's a deciding factor is that, well, my advisor knows this, so I need to learn this to be able to communicate with them. What was I going to say? I think I lost it. But the good news is that after your first package, the others come easier because then you have the concepts in your head like, okay, how do I merge rows? How do I merge columns? How do I do this? And then you just have to find whatever this is in their documentation or have someone give you examples to work from. So Anywho, all right, so this semester, the material is divided into sort of 3 overarching sections. This week and next week is review of general linear models and the concepts that I need you to take with you out of them to be able to extend into longitudinal models, as well as a summary of repeated measures ANOVA and how it is and is not the same thing as what we're going to be doing. I build this in here because I have found that in some places repeated measures ANOVA doesn't get taught at all, and in other places it's like the bread and butter of what you learn in your first year stats sequence. So like in psychology, everything with some kind of repeated measures ANOVA. In other places, it's not a thing. So I want to make sure that you have that. That way, when some well-meaning reviewer says, why can't you just do an ANOVA, you'll have an answer for them. Or you can say, I did do an ANOVA as you know it, but here's why it's a little bit different, and why it needed to be different. Then we move into what I call unconditional models, where, as crazy as it sounds, you're building a model that doesn't have anything you care about in it. All that you have in it is time, because time turns out to be a big deal. You have to make sure that whatever trends are present in the data for change over time or fluctuation over time, changes in the means of your outcome over time, changes in the variance, changes in the covariance, all that stuff is hammered down so that you can then add predictors that you care about. And so we'll be covering models that are designed for longitudinal data that show what I call fluctuation, where you're not expecting some sort of systematic change. You just have a lot of occasions from the same person to look at how things co-vary within a person together versus within person change, or what would be called growth curve models as a framework. That's a synonym for that idea, where time is structured meaningfully with enough distance in between so that you see change occur. And then we get into conditional, which is adding predictors. And so I'm hoping to get further in this iteration of the class than I was able to get last time by skipping over some of the GLM stuff and giving you places to review if you need that instead. But I'm hoping to get through what is known as time invariant predictors, so variables that are measured only one time versus variables that are predictors that are measured multiple times. And the latter is a thing. I could spend probably 2 months on that topic alone, but we're going to try and hit the high points at the end of this semester, because it turns out that most time varying predictors should actually be treated as another outcome to make your multi-level longitudinal model multivariate at the same time. So repeatedly measured over time, and then different types of repeated measures happening simultaneously. That's where we're going to end up. I have elected not to include models for not normal outcomes in this class. I've got plenty of examples of those, though, if that's something that you want to dive into and you've seen those sorts of models for single level models before. So that's the plan. All right, are we excited? Okay, any questions so far? All right, checking the time to make sure that I don't keep talking at you all afternoon. All right, so big picture. Longitudinal data, as we've described, repeated measurements of the same something over time, sampling unit of whatever kind, or repeated measures data, repeated conditions, trials, items, whatever, they all fall under one general category of what you can just think of as multivariate. Whenever you are predicting multiple outcomes from the same sampling unit, that's multivariate data. And so multivariate models and multi-level models are kind of trying to do the same thing. They're trying to account for the fact that data points from the same sampling unit are going to be more related than data points from different sampling units. And so these are just choices for how to best represent those within unit relationships and differences in variance that they cause. So the kinds of outcomes that we're working with this semester, we are assuming they're interval. So that means that a 1 unit difference along the scale has the same meaning as a 1 unit difference. So a score of going from 5 to 6 is the same difference as a score going from 27 to 28. In subscales, this would mean that each item contributes to the same extent. And I will say that yes, there are models for other kinds of outcomes. Of course, you can have a longitudinal analysis of a binary outcome, a count outcome, a nominal outcome. Of course, you can do that. But those models are just a layer of complexity further and really aren't all that different in terms of the concepts once you get around that extra needing a link function thing, but to estimate them is a lot harder. So I've chosen to not do those this semester, but if you come back in the fall, this fall I'm teaching the clustered multi-level modeling course. I will get to those in that course because we don't have to talk about time. And so that saves like a whole month of programming. We are assuming that the scores have the same meaning across observations and across occasions. So we're talking about what is known as measurement invariance. That if you have a measure of, say, childhood anxiety, you can think about that as the same trait whether the child is 3 versus if you follow them to when they're 4, when they're 5, when they're 6. If your trait changes in a way that you need a different kind of measurement, I am assuming that you've already dealt with all of that before you came to this class. So there are ways to handle that. You can use latent trait measurement models, plug from my other class, also coming back in the fall, to address when instruments need to have different items over time so that the measurement of the trait changes in a meaningful way that maps onto how people change. You can do all that, just not in this class. So I'm assuming that all that has just been handled, it's been fixed, whatever euphemism you want to use for I'm not going to worry about that right now. And we're just working with interval outcomes. And I have here in capital letters, fancy models cannot save you. So I've heard this from people before, like, well, I only have 2 occasions, but I thought that if I ran a multi-level model that would somehow tell me something different than my t-test, and I got news for you. Or if you have a different measure at time 1 than you have at time 2, you can't talk about how that thing changes if it's not the same thing. So those basic problems of design cannot be overcome by any of this. So all the stuff you learned about the importance of design and continuity and all that still holds. How many occasions do you need is a frequent question. The answer to that, how many occasions do I need, is always more. No matter what, you need more. If you only have 2, then I hate to tell you, but after like this week, I got nothing for you. If you got 2 occasions, ANOVA is fine for that. You can do it with REML instead of least squares if you have missing data, but otherwise, none of the things I'm going to show you, you can do with 2 occasions. 2 occasions is the minimum for measuring change, right? Where I was, where I am now. But what you can't do is talk about how people differ in change. So if I have 2 points for my behavior, I'm going up. How well does a line fit those 2 points? Perfectly. Yeah. So there's no way to indicate whether I need a different line than someone else, or we both need the same line, but the line is measured with error. For 2 occasions, you cannot differentiate what is individual differences in change from what is everybody changes the same with measurement error. They are both equally accurate ways of characterizing the data. However, no measurement error is kind of a stretch. So with 2, you can't distinguish those 2 possibilities. So post-test, pre-test designs, those kinds of things are a terrible idea for measuring change. More data is better. And with respect to more, the thing about these models is that you have to quantify more what. So if you're doing a longitudinal study where units are measured over repeated occasions, more occasions gives you more flexibility in indicating nonlinear kinds of change, right? So the other thing about 2 points is that the line between them is a straight line. Has to be. But if you're studying something that you think levels off or starts to head direction Or maybe it starts slowly and then it creeps up and levels off. There's all kinds of different patterns of nonlinear change. The more occasions you have, the better you can nail down what kind of pattern you have. The more power you will also have for testing the effects of predictors that are measured at each occasion. So if you have y at each occasion and x at each occasion, your power is going to come from how many occasions you have. But more also applies to the units themselves. So more people you also need to consider simultaneously to be able to have more power to detect and predict individual differences. So we'll be talking about individual differences in the mean. So the intercept, you'll see me do this y-axis gesture right here, versus individual differences in change, versus individual differences in, say, acceleration of change or deceleration of change. You need more people to be able to characterize how people differ from each other and to predict those. So power analyses for these sorts of designs are complicated because you need more of each kind to be able to test hypotheses that correspond to each kind. Question from the audience: is first difference okay for 2 periods? Yes. And so what changes it really measuring? Hard to say. So with only 2, you have one kind of change, and it's hard to make conclusions about it because you don't have anything to compare it to. So pre-test, post-test is sort of the bare minimum for using these models, but it's really not enough to do any of the cool stuff that I'm here to tell you about. For those of you who want to know how many occasions do I need, here's a picture. So this is from a classic article, Willett 1989, who is describing on the x-axis the number of occasions. The y-axis is a measure of slope reliability. So how well you can separate the signal of individual differences in change from the noise that you're pulling it from with the repeated data as a function of the signal to noise ratio, so the strength in the data. And what each of these curves shows is a big jump from 2 to 3 in your reliability of being able to measure change. So you get a big jump from 2 to 3, and in most cases with sort of low signal, you'll get another big jump from 3 to 4. And at some point, like 5-ish, things start to level off. But the more occasions that you can put in there, the better your chances of detecting change of different kinds. And so we'll talk about not only continuous change, but also discontinuous change. So like if you have a study where you do something, watch what happens, do something else, watch what happens. Like you want as many points as possible within each of those regions to be able to see what's going on locally as well as sort of in the overall trajectory. Okay, I think I'm caught up on the chat window. And then yes, more people, more power for that as well. Go ahead. There you go. All right, so vocabulary. Welcome to the world of never-ending synonyms. There are so many words that people use to talk about the same damn thing. And I want you to become fluent in being able to switch your words as needed to talk to people. So in our context, we're talking about repeated occasions for the same, let's say, person. Then we will conceptualize outcome variation as belonging to sort of 2 different levels. There's between person and there's within person. So synonyms for between person, in multi-level modeling, it would be known as the macro level. It will be called level 2 in our analyses, and it refers to inter-individual differences. It also refers to time invariant kinds of relationships. And the good news is that all longitudinal studies have this kind of information because all longitudinal studies start as cross-sectional studies. So before you can measure them over time, you got to measure them once. So you have differences between people that are time invariant, that are cross-sectional, that are macro level, that refer to inter-individual differences. Back in the days of simple linear regression, The E that's at the end of the model that describes discrepancy between how well the model predicts your outcome and what it actually is, that is between person differences because you have one outcome per person. What longitudinal studies get you is this extra kind of variation, which is due to the repeated occasions. So within a person, we have within person micro level, level 1 variability, otherwise known as intra-individual differences or time varying relationships. All of those words go together. And so that's the idea that you can hold a person as their own constant and then sort of isolate what might be causing or predicting differences relative to their normal level. So that's the logic of within person designs, is to be able to isolate that different level of variability. So most hypotheses in terms of social sciences you can think about as pertaining to one level or both levels. So for instance, let's think about the idea of pandemic drinking. People drink in response to stress. That idea is a within person hypothesis. In response to stress conveys that I'm fine. I'm not having wine. It's fine. It's fine. Oh, he was going to be home for 3 months? Say what? Okay. Maybe we'd throw an extra bottle in the Hy-Vee run this week. In response to stress is relative to my own sort of baseline. If I experience an increase in stress, maybe that causes, dare I say, relates to an increase in drinking. Or maybe if I drink too much, then I feel stressed. Like it could go either way. But that's a very different kind of idea than saying that people who drink more than other people are more stressed out than other people. It's a different point of reference than other people is referring to sort of stable trait kinds of things versus relative to what I'm used to is a state transient kind of thing. And so it may be the case that some relationships hold at the between person level, some hold at the within, and some hold at both. And they can be in the same direction or they can be in different directions. So if I think about blood pressure and exercise, people who are in shape, meaning that they have like a low, that they have sort of low blood pressure, tend to be people who would exercise more frequently. So more exercise goes with lower blood pressure. But what happens when you're actually exercising? Your blood pressure goes up. So it's the same two variables, but they mean different things. One is a proxy for physical health and one is a proxy for movement. So in thinking about research questions, it's important, dare I say essential, to clarify, like, what is your reference point for more than? Is it more than other people? Is it more than usual? Or is it some combination that would be applicable to both? Chat window catch up here. Can between person also be between groups, like low-income people and high-income people? Yes. People can be characterized by grouping variables or by numeric continuous variables, quantitative variables, and then measure change within people within that group. Yes. So would that be like intergroup and intragroup? Intra, in your example of within a group of people, is still a level 2 intra because you're talking about differences between people of a certain demarcation. That's still between people. In this taxonomy, within would be within a person, yesterday versus today. Okay. All right. So we can have interactions of the two. So maybe people who tend to have more of a trait on average are differentially susceptible to acute increases as well, or less susceptible because they're used to it. So those types of ideas that within person relationships can vary by who you are, that's known as a cross-level interaction, where you have person things interacting with time varying things. And longitudinal studies are useful for looking at those as well. What if you want to measure how much change happens within a person who is part of a certain group? Yes, you can do that. So once we have our model of change, so we would describe sort of what happens on average and to what extent each of the terms that we need to describe change varies across people. So those terms will be known as fixed and random. We're getting to that vocabulary, not yet. Then you can talk about how average change differs as a function of person characteristics. So time invariant predictors are variables that are measured once for a person. So even if you think they change theoretically, if you only have one measure, you're stuck with it and it's time invariant. And so yes, you can look at how change varies as a function of time invariant things and how fluctuation can be the result of time varying things. So yes. All right, how are we doing? So recapping, between person, level 2, macro, inter-individual, time invariant, all those words go together. Within person, micro, level 1, intra, time varying, longitudinal, all those words go together. Now, more words, trying to describe what kind of longitudinal data you have. And this is the way that I think about it, as a continuum of different kinds of data of which there are discrete endpoints. So on the left-hand side is what I would call within person change. And this is the classic idea of repeated measurements that are spaced far apart enough to where you can see change happen and you can see individual differences in change. So the schematic here that I have is the outcome on the y-axis, the time that's being measured, time in study on the x-axis, and these would be different lines for different kinds of people. So some people go up, some people go down, and our question is, how do we predict who's likely to increase and who's likely to decrease and stuff like that? So the term for this kind of analysis is a growth curve model. Now I have my air quotes going because that term is used no matter whether or not they're growing and whether or not they're curving. So I could have lines of older adults, sorry, I got to go this way, like heading down a hill because of aging or disease, and that would not be a decline line analysis. That would still be a growth curve analysis, even if they're going down. I didn't make it up, but this is the terminology that everybody uses. For those of you who want to learn latent growth curve models or latent growth curve analyses, that's when you fit the same model in M+ instead. The term latent gets thrown around if you set up your random effects as latent variables, because random effects and latent variables are the same thing. So that term doesn't actually add anything in most cases, unless what you're talking about is that you're having growth of a latent variable instead of an observed variable, which you totally can do, but that is a second order latent growth curve model. So there's like words that just get stacked and stacked on top of each other, and a lot of them are synonyms. So one of the things I'll help you do is sound as fancy as possible. That way you can whip that stuff out in your job talk and sound like $1 million. So growth curve models is on one end. On the other end is what I call just fluctuation, where you might have curves, lines that look like this. So there's no systematic effect of time. Like if you just ask somebody every day for a week, hey, how well did you sleep last night? How stressed did you feel? Did you eat healthy today? Did you get any fights today? Those kinds of studies, you're not trying to fix them, right? You're not trying to make them sleep better or make them eat healthier. You're just asking. Now, they might start making those choices because you're asking and they're thinking about it, but that's a whole separate thing. Then that would fall under the left-hand side, but unintentionally. But these sorts of studies, ecological momentary assessments, what used to be called Palm Pilot studies, but you all are too young to know what that is probably, daily diary studies, intensive longitudinal studies is another word that goes with that. You're just trying to get as much data as you can per person so that you can kind of see what makes them tick. and study how things relate to each other within persons. But most of the constructs are not things that you would expect to necessarily change in the same way across people. And then you can have everything in between. So I've seen cases where people were like, I'm going to measure change, and they had no change. And then there were things like, I'm going to measure fluctuation, but they induced change. So, as an example of that, I know of a study where back before the internet was a thing, they used to call people every night. And they'd say, Hey, how was your day? Did you get any fights today? Did anything stressful happen today? And if the person said yes, there was 10 minutes of follow-up questions. Well, it didn't take the respondents long to figure out that if they said, Nope, it's all good, they got off the phone 10 minutes earlier and they still got their compensation. So you saw this decline in stressful events that happened across the study. So that actually then requires the change models because it is changing over time, even though it wasn't supposed to. So one of the things that we will do is no matter what you anticipate, check the data. Because if there are systematic effects of time sort of in common across people, and especially if people vary in those, then we got to do something about it. We got to put something in the model that predicts that. So any of you thinking about particular longitudinal studies and how this might apply or have questions about that?
So we're doing an app-based study with EMAs, recording people's levels of stress or anxiety or depression across pregnancy in the first 2 years of life.
Mm.
So I wasn't sure how that data gets analyzed, so I guess I'm going to be learning.
Yeah, so do you expect that things align themselves differently as a function of like where the due date is, sort of before and after pregnancy, and then that's sort of a
Yep.
salient event, I would think.
Yep.
Yes,
Yep.
having been there. So yeah, in your case, the x-axis for what time is might have a 0 point at where your subject gives birth.
Uh-huh.
So you may have to sort of realign different people to have that common 0 so that you can look at changes leading up to that point and then changes after that point.
Mm-hmm.
Does everyone in your study have a 0 point? Like
Yep.
everyone gives birth at some point?
Yep.
Okay. So then you don't have to worry about what would be known as censoring or when the time metric doesn't necessarily have an endpoint or a common point across people like in survival models. So
Mm.
yeah, I would say that chapter 10 of my book, Alternative Time Metrics, would speak directly to that. Talks about different ways of aligning people across time. Yeah, we'll get into that. So,
Great.
yeah. Others? No. Okay, that's fine. Okay.
Actually, sorry, I have a
Yes.
question. Yeah.
Where are you? There you are. Okay.
Yes. So then when we have a, if I miss, sorry, if I miss something, I'm sorry. But like for within person fluctuation, we use just like a multi-level longitudinal model to analyze the data. Am I
Sure.
correct?
Yeah.
Okay. Okay. And
Yeah.
like how would you like a distinct? Yeah, because as you say, some data, might be very between change and fluctuation. Like how would you make a decision? Or like, this is more like a change. So like I go with growth curve model, or this might be fluctuation. Like I just use a multi-level. Like
My
what kind of
answer is
rule do you
always
make?
it's an empirical question.
Mm-hmm.
So we'll do tests, we'll make pictures, and we'll see if the means look like they're changing in a particular way that would merit terms in the model being included. And in absence of that, maybe you don't have time as a predictor. So it's the same kind of model. It's just that time's not part of the story. If like in this picture, if people like a main effect of time would be the slope of the line along the x-axis, right? Each of these people, at least to the best of my PowerPoint drawing ability, is flat. So time does not have a main effect. But what it does have, though, are differences in variability. So one of the extensions of these models that we may have a chance to touch on is models for predicting differences in within-person variance.
I see. Okay, it's gonna be more like a traditional clustering model.
Traditional what? I'm sorry?
Clustering model.
Yes, yes.
Because like we control the level 1 variance, like within person. Okay.
Yes, yes. Our level 1 is time and level 2 is person instead of level 1 being person and level 2 being cluster.
I see.
Yep.
Okay.
Yeah. In this class, the terminology is, I'm trying to keep it straight, but yes, all the things that we did in clustered are going to apply directly. Yep. And then Kelly has one, fluctuation. Care to comment? Oh, she's talked to me about it before. Yes, she has discipline referrals within students across school years. So they're interested in predicting referrals or consequences of referrals, but they wouldn't necessarily increase as the student progresses through school. Yep, same kind of thing. So, yep. So it doesn't matter if you expect people to change or not. We'll watch for it. We'll put it in the model if it's needed. But all of these models are equally applicable whether that happens or not. That's the take-home message. All right, I'm keeping an eye on the clock so I don't run over because I'm just so excited to see everybody and talk about this. But any questions before we wrap up for today? All right, then thank you for showing up. I really love everybody here. Office hours start now if anyone wants to hang out. Otherwise, I'll see you Thursday. Take care of yourselves.
Thank you.
Your office hours are in the same link,